So in the Lewis model, we represent the valence electrons as dots around the element symbol. We're concerned with the valence electrons because those are the ones that are involved in bonding. They're in the highest, the outermost principal energy level. So those are the ones on the outside, and they are the ones that interact with other atoms. They're the most loosely held. If you're going to remove an electron from an atom, it's going to be the valence electrons. So the Lewis symbol. Let's look at the Lewis symbol for oxygen. So we use the element symbol. Element symbol for oxygen is an O. And then we look at the periodic table to tell us how many valence electrons does oxygen have. It's got 6. It's in group 6. It has 6 valence electrons. And so we're going to put these as dots. 1, 2, 3, 4, 5, 6. 6 dots. So there's the Lewis symbol for oxygen. Now, there are some guidelines. We place those dots on 4 sides, top, bottom, right, and left, with a maximum of 2 per side. It's just an easy way to visualize the valence electrons. You could draw them in a circle, but then it's harder to see how many you have. If we go back to this, and I draw another Lewis symbol for oxygen, it's hard to look at that immediately and see, oh, there's 6 electrons. Once you look at a few Lewis symbols, you recognize that this is 6, because this 8 would be like this. It's a little bit like the spots on dice, right? They're always in the same arrangement, so you can look at the 5, and you don't have to count the spots. So that's kind of... Yeah, there's only 4 places, 4 sides, top, bottom, right, and left. And then there'll be a maximum of 2 dots on each side. And this actually corresponds to the S and the P orbitals. So if we think about, for the main group elements, the valence electrons are going to be in the S and the P orbitals of the valence shell. And could be 2 here, 2 there, 2 there, 2 there. So that's 4 places, maximum of 2 electrons per place. So it's not a coincidence. We say that atoms with 8 valence electrons have an octet. Octet 8, right? They're particularly stable. We notice that with the noble gases. They all have 8 valence electrons. Helium's the little guy, so he's an exception. We say he has a duet of 2 electrons. And he's very happy with that. He's too little to handle. He couldn't handle 8 electrons. That'd be too much for him. So we talk about the octet rule. Atoms will transfer or share electrons to achieve an octet of valence electrons. So everybody's trying to be like the noble gases, 8 valence electrons. That's the goal. And so they'll transfer electrons to do that, or they'll share electrons to do that.